This is my lab report for Lab 4 oscillations. For the introduction, the main concept used is Newton's second law, which is the change in momentum equals force times the change in time. And for the forces acting on the system, we have the net force is equal to the force of gravity plus the force of the spring, which can also be written as the force of the spring, which is Ks, plus the force of gravity, which is mg. Additionally, we need energy concepts, mainly the energy principle, and because there's no work done on the system, total energy remains zero, so kinetic energy plus potential energy of the spring plus potential energy of gravity will equal zero, and then kinetic energy is equal to 1/2 mv squared. The potential energy of the spring is equal to 1/2 ks squared, and the potential energy of gravity, or gravitational potential energy, is equal to mgy. For the observed data in Tracker, I found the initial position to be negative 0.11 and negative 0.668 meters. The initial velocity is zero because the object is released from rest. The mass is 0.402 kilograms, which is given. And the time period I calculated by finding the average time period of 3 separate oscillations, and it was found to be 1.519 seconds. For the observed data, to calculate the gravitational force, we just use Fg equals mg, and we find that the gravitational force is negative 3.94 newtons. And then for the spring constant, we use the equation, the time period is equal to 2 pi times the square root of m over k, and when we rearrange to solve for k, we get 6.878 newton per meters for k as a spring constant. And then the relaxed length of the spring can be found by using the force of gravity equaling the force of the spring. And then when we solve, we get that the relaxed length of the spring is 0.127 meters. For the glow script, we first have to set up the initial conditions using the data that was just shown. So we set the mass of the ball, the position, and the initial velocity. Then we use this set of code to update the length of the spring by calculating L and L hat. Then we calculate the system energies by using the equation shown before. So we have kinetic energy, potential energy of gravity, and potential energy of the spring. And then the total energy is just the sum of those three. For the loop, we define the energies, and then we input the gravitational force, which was found previously, and then we put the spring force and net force, and then we update the ball's position and velocity using the momentum principle. Then we update the spring using the same code as before to find the updated length of the spring, and then we calculate the changing energies using the same formulas shown previously. For the graphs, we have the position time graph in the x direction and in the y direction, and the reason for the discrepancies could have been because of drag not being taken into account, as well as errors when tracking the object on the tracker software. Finally, we have the discussion questions. So the energy principle is satisfied because the energy of the system is equal to the energy of the surroundings, and as it can be seen in this graph, the orange line is the total energy and it remains zero, which follows the energy principle. Additionally, the sum of all the energies will always equal zero, which can be seen in the graph as well. Finally, the time period of the x component I found by subtracting the time it took for 3 total oscillations and dividing it by 3. And I did the same method to find the y component. And the difference for these time periods could be because of an incorrect value of k used to find the time period.